Today's lesson is on hypothesis testing about a population mean. The first problem states, on average, a cow can produce 6.37 gallons of milk per day. A graduate student designed an experiment to see if a cow listening to music would increase milk production. She tested 38 cows for several days by playing music during daylight hours. During the experiment, the mean daily milk production was 6.65 gallons. If it is known that the population standard deviation for daily milk production of cows is 0.98 gallons, test the claim that playing music for the cows will increase the mean daily milk production. Let the level of significance be 0.04. Here are the things that we need to do in order to do a hypothesis test about a population mean. First, we need to determine whether it's a test of mean or proportion. Well, I already stated this is a test of mean. Then, we need to determine the correct sampling distribution. If it's a test of proportion, no matter what, we would use the standard normal. This is not a test of proportion, as I've already stated. If it is a test of mean and sigma is known, we use the standard normal distribution. If it is a test of mean and sigma is not known, we use the t distribution. Just like the t distribution that we used for some of the confidence intervals about a population mean problems. Let's just figure out part B right now, and of course we'll come back to it. But if you look at the wording, it says, if it is known that the population standard deviation for daily milk production of cows is 0.98 gallons. Well, right there, that's giving you sigma. There's only two ways, basically, you're given sigma. It'll either say the population standard deviation is, or it'll just say sigma equals. Let's determine if this test is a left-tail, two-tail, or right-tail test. Set up the null and alternate hypotheses. Determine the critical values and rejection regions. Sketch the diagram of the distribution showing the critical values and the rejection region. Calculate the test statistic. Place a mark on the diagram where the test statistic should be. Compare the test statistic to the critical values to see if the test statistic falls within the rejection region. Conclude whether we reject the null hypothesis or fail to reject the null hypothesis, and then state the conclusion in layperson's terms. For all hypothesis testing problems about a population mean, we must find the following first. X bar. And that's the sample mean. That's the experimental mean. For this problem, we know that it's 6.65. And it says that right over here, it's 6.65 gallons with the experiment on the 38 cows. We need to find the total number of people or things in the sample. For this problem, n equals 38 because there are 38 cows. This is the Greek letter nu, lowercase. We also refer to this as the degrees of freedom. And the calculation is pretty easy. It's just the number of things or people minus 1. So for this problem, we have nu is equal to 38 minus 1, or 37. We only would need to use nu if sigma is unknown for the problem. Then we have mu. We've already worked with this many times. This is the population mean, or what we accept as truth before this experiment is conducted. So it says, on average, a cow can produce 6.37 gallons. That's truth. We have the level of confidence. Sometimes it's given as a level of confidence, sometimes a level of significance, sometimes it'll say let alpha equal, which is the same thing as the level of significance. The level of confidence is 0.96 because the level of significance is 0.04. Alpha is basically the same as the level of significance, and that would be 1 minus the level of confidence. But in this one, we were just given the level of significance as 0.04. Sigma, the population standard deviation, if given, we certainly need to put that down. And S, the sample standard deviation, or an approximation of a sample standard deviation by an acceptable method, such as the range rule of thumb. And we already learned about the range rule of thumb. Determine if this is a test of mean or proportion. It specifically uses the word mean or average, so yeah, it's going to be a test of means. We have to determine the correct sampling distribution. Since sigma is given, the correct sampling distribution for this is the standard normal distribution, and that's one that by now you should be used to using. Determine if this test is a left tail, two tail, or right tail test. Well, let's analyze the problem a little bit. Normally, cows produce 6.37 gallons of milk. We want to see if we could increase milk production. And as we can see, there sort of was an increase to 6.65 gallons. The whole purpose of this hypothesis test to see if this is enough evidence to suggest that cows listening to music would increase milk production. It seems like enough evidence, but we don't know that for sure. This would be a right tail test because we're testing for that increase in. Set up the null and alternate hypotheses. The null hypothesis is mu is equal to 6.37. The null and alternate hypotheses will always have a mu equals to, and either mu is greater than, as in this case, because it's a right tail test, or for a left tail test, it would be mu is less than, or for a two tail test, it would be mu is not equal to. The number that we use on the other side of the equation or inequality will be the same for both, and it always comes from what we accept as truth. In other words, what we knew before this experiment was conducted. And as it says right here, we know it to be 6.37, although this new study showed maybe 6.65. This would be mu equals 6.37, and because it's a right tail test, mu is greater than 6.37. We have to determine the critical values. The critical value or values come from the level of confidence and the correct sampling distribution. So we know we're using the standard normal distribution. We know that we're using an alpha of 0.04, and because it's a right tail test, we don't need alpha over 2. The critical values, we would use norm.s.inv of alpha, and we don't divide alpha by 2. This one, we would have norm.s.inv, we would click on the cell for 0.04, or the critical value would show up as negative 1.7507. But because this is a right tail test, we would use the positive critical value, which is just the absolute value of the negative. So it's 1.7507. And again, I will go over all of these in spreadsheet mode. Here are all the things that we have. These are the original parameters that I set up. This is a test about a population mean with sigma known, so the correct sampling distribution is the standard normal distribution. The keywords increase usually indicates that it's a right-tail test. Sometimes it doesn't. Sometimes the words are tricky, but for now, let's just accept that. The null hypothesis is mu is equal to 6.37, and the alternate hypothesis is mu is greater than 6.37 with a critical value of 1.7507 that we got from using a spreadsheet. The rejection region is, since it's a right-tailed test, to the right of my critical value, and it's this whole region over here. And now we have to calculate the test statistic. The test statistic is x bar minus mu over sigma over the square root of n, and that's if sigma is known, as it is for this problem, or the test statistic is x bar minus mu over s over the square root of n, basically the same formula if we have s or an approximation for s. In other words, if we have a sample standard deviation or anything that we could use to approximate a standard deviation. So for this one, we would have 6.65 minus 6.37 over, all in parentheses, 0.98 over the square root of 38, which is approximately equal to 1.76126. And now we have the ability to complete the hypothesis test. Let's take a look all the way over here. My critical value is 1.7507, which is this border right here, this one in red. My test statistic is 1.76126, which is hard to see, but it's right here in green. Which means that my test statistic does fall within my rejection region. It's there, but it's barely there. And you can see that it falls in that blue area, so that means it's in the rejection region. Since the test statistic falls within the rejection region, we reject the null hypothesis. So let's take a look at the null hypothesis. The null hypothesis is saying mu is still equal to 6.37. But for this experiment, we reject that. That's gone. In a sense, we're sort of saying we accept mu is greater than 6.37, but we tend to keep away from that word accept. It's a one-tailed test. We reject the null hypothesis, and in layperson's terminology, we would say with a 96% level of confidence, it seems that playing music for the cows will increase the mean daily milk production. So let's go to spreadsheet mode. We're going to do the same problem that we just did, and we'll build the spreadsheet together. For this one, I'm going to pretty much take my time. On the future problems for this, I'm going to just do these two things simultaneously, and I won't do as much explaining. So, first thing, x bar. We've already discussed this. Here's the original problem. X bar is what we got as the experimental mean, and that's going to equal 6.65, and you have to type that in manually. N, well, that represents the number of things or the number of people. In this case, we have cows, so there were 38 of them. Nu, well, I'm going to type in equals whatever n is minus, and then 1. My level of confidence for this problem was not simply given. It was given as a level of significance, but we will put it in as a level of confidence of 0.96. And alpha, that will always equal 1 minus whatever I have for my level of confidence. And alpha over 2 is exactly what it looks like. It equals alpha divided by 2. Mu is the value that we have prior to this little experiment or survey or whatever it is that we're doing. And that was 6.37. That's the value that we accept as truth unless this little experiment shows us otherwise. Sigma or S, there's a reason why I put down either or here. And that's because in this green area right here, that'll just deal with everything if it is a sigma, and this little red area if it's an S value. You just have to know which box, you just have to know at which box you're supposed to look in order to determine what your critical values end up being. So for this one, sigma is simply, what do we have? 0.98. If it's a sigma, I'm just going to do what we call a direct cell reference. It's just going to equal whatever I have where I put sigma or S. My left tail critical value, if sigma is known, we know that the correct sampling distribution for this type of problem is the standard normal because it's a test of means and sigma is known. So we will say equals norm dot s dot inv, open parenthesis. I'm going to click on my alpha value. Then I'm going to close that parenthesis, press enter. For a right tail test, we take the absolute value of whatever we got for the left tail test. So I'm going to just type in equals ABS. That's for absolute value. Click on the cell above, close my parenthesis, press enter. For a two-tail test, we would just type in equals norm.s.inv of, and I would click on the alpha over 2 value, and this is going to give me a negative result. Now, don't worry too much about that negative result. It's really both negative and positive. If you had a two-tail test and you were asked on an assignment to state the critical value, then I would just put the positive one in instead of the negative one, or it might say put it in a comma separated list if it's a two-tailed test or if there are two critical values, and then you would put in both the negative and the positive. But when in doubt, for a two-tailed test, just type in the positive critical value. We'll come back down here to this little box in red if sigma is not known. It doesn't apply for this problem because sigma is known in this problem. Let's look at our test statistic. The formula for the test statistic calculation is shown right here. This is the one we would use because sigma is known. We take x bar minus mu in a numerator, and we divide it by sigma over the square root of n in the denominator. Let me type that in right here where it says test statistic and the cell next to it. It will equal, open parenthesis, we take our x bar value minus my mu value. Hey, and we're talking about cows. Mu. All right, bad joke. Close parenthesis, divided by, open parenthesis, sigma or S, it doesn't really matter. So I'm going to just click on this cell, the one that says sigma or S, divided by SQRT, that's what we use for square root, of n. We're going to close the parenthesis for the square root function and close the parenthesis for the denominator, press enter, and we get that result that I show right here of 1.76126. Now, we compare this value to a right tail critical value, and let's just take a look at the image that I have for this. And as you can see right here, I have critical value of 1.7507, and my test statistic is 1.76126, and those are the numbers right here and here. And the test statistic does fall in the rejection region, so we reject the null hypothesis. And since we reject the null hypothesis, we can say with a 96% level of confidence, it seems that playing music for the cows will increase the mean daily milk production.